Hello, everybody. I got a suggestion from a student that I stream video of some of the example lecture code that I create and then go over during the lectures. Um, a lot of the code takes me a really, really long time to write, and if I streamed it, it would be hours long and would be full of mistakes. Not that this won't be. But I thought I'd give it a shot, at least for a specific example. So we've been getting a lot of questions about RecyclerView. It's been in a couple of the homework assignments now, and people still don't seem to be understanding it. So I thought I would create an example of a very simple recycler view that sort of demonstrates the use of the different parts of a recycler view, including the recycler view itself, the adapter, the view holder, that all of that stuff, to hopefully provide some clarification as to how the recycler view works, what it's used for, what the view holders are for, what the adapter is for, and so on. So I've already started the Lecture 17 project. This code is checked into GitHub. I will check in this code that I'm about to write into GitHub when I've finished it, and hopefully you guys will find this video useful. Anyways, I'm going to start by creating a new package. As you know by now, I like to keep all of the different parts of each lecture because I cover multiple topics. I don't want to mix them all together into one big application that's hard to understand, so I try to put different parts into different packages. So I'll start by creating a recycler package. Maybe I'll call it RecyclerView inside the main lecture package. And then the first thing I'm going to do here is just create a new fragment. I'm going to make it a blank fragment, and I'm going to uncheck these nasty little checkboxes to make sure that I don't get all of that extra code generated. And I'm going to call it something really original, like RecyclerView fragment. Okay, so now I've got my fragment. It's mostly empty, and if everything went well, I should have down here a new layout just for this RecyclerView fragment. It's green because I have added GitHub as a source control repository, and that just flags this file as having been added to the repository but not pushed to the repository actually on GitHub. So it's in my local repository, but it hasn't been pushed to GitHub. You'll notice different colors, different colored files in the project list, but don't worry too much about it. So the first thing I'm going to do is show you actually that I've already added the RecyclerView library to the application, which you can see right here. So I'm not going to go through those steps right now. It's already there. But I'll go into my layout, and I always forget android.support.v7.widget.recyclerview, I believe, is the name, the full class name. Now remember, because this class comes from a support library, you have to type in the full class name of the RecyclerView to add it to your layout. You can't just type RecyclerView in the same way that you can type TextView or the names of some of the other standard widgets. Anyways, I've added my RecyclerView. I like things to be lined up, and the indentation of, in particular, the layout or widget that's at the root of a layout is all messed up by default in Android Studio, so I like to fix it. I need to give an ID, so I'm going to just type ID, autocomplete, autocomplete, and I like to name all of my IDs with the type of the widget first because it makes it really easy to find later. I'll just call this guy RecyclerView example. I'm going to keep the width and height at match parent, so this will fill the entire screen in the host fragment because I don't really want to add anything else. And then I'm going to delete the text view, the hello world text view that was added by Android Studio by default. It's one of the more irritating things that Android Studio does, because not only does it throw this text view in there that you delete 99.999% of the time, but it also adds the hello world value to your strings.xml, which is really irritating as well. And no matter how many times you remove this, every time you create a new fragment or an activity, it's going to throw another one of these hello worlds in there. There's probably a way to turn this off in Android Studio. I don't know how to do it. Anyway, I've got my layout, which just contains a recycler view, and I have my fragment, which so far the only thing it does is inflate the layout that has a recycler view in it. So the first thing I'm going to do here, I don't want to return my view immediately after it's inflated. I'm going to want to do some things with it, so I'll create a variable and assign it to the inflated view, and then I'll put a few carriage returns in here, and then I'll return the view at the end, and I'll get back to this. So the next thing I'm going to do is create a layout for the views that are going to be displayed in the RecyclerView fragment. So remember, the RecyclerView can displays a list of things, or it can be a grid. It depends on the layout manager that you use. But I'm going to use a linear layout, which by default displays a set of views in a vertical linear layout inside the RecyclerView fragment. I'm going to use a very simple text view. This you get for free from the old list view fragment and widget that we are not using anymore, because RecyclerView was introduced to the platform to replace that. It's a little bit harder to use, but it's a better widget, and you don't necessarily get text view layouts for free. But I'm going to create a new layout resource file by clicking on layout under my res folder and selecting the layout resource file option. If you click on another part of the res folder, you'll get either the generic resource file option, or if I click in values, I'll get values resource file option here. I want a layout, so I'll right click on the layout folder, select new layout resource file, and then I'm just going to give it a simple name, something like RecyclerView layout, just a generic name. And again, it actually generated a nice linear layout, but I'm going to change this. I just want it to be a text view. I'm going to give my text view an ID. Again, autocomplete text view for RecyclerView, whatever. Nice long name. Getting rid of the orientation because that doesn't really apply to text view. Again, fixing the spacing here just to make it nice and consistent. That's my OCD, you don't have to worry about that. I'm going to keep it at match parent. For now, I may change that to wrap content if it doesn't display properly. So now I have a simple layout that is just a text view, and it has an ID so that I can refer to it in code. The next thing I'm going to do is switch back to my RecyclerView fragment, and I'm going to add an inner class here to be my view holder. Now, why am I going to use an inner class? That'll become obvious later, but just sort of to give you a little sneak preview, I'm going to add on-click listeners to the views in the RecyclerView, so that when the user in the emulator taps on one of these items, that it'll actually pop up a dialog or start a new activity or whatever. But I want the method that is called when the view is clicked to actually be a method that's in my fragment. So I don't want this to happen in the view holder itself. I want to be able to use the fragment. So because I might want to do something like start an activity, which will require me to get the RecyclerView fragments host activity to create the intent to start that activity, or I might want to pop up an alert dialog, which would require me to use the fragment itself to start the new fragment that's floating on top of it, something like that. But the view holder is not a fragment, it's not an activity, it's not a widget, so it doesn't have access to the kinds of things you need, like a context, for example, to start a new activity. So I don't want the view holder to try to handle those on-click events itself, so I want to pass them to the fragment, and it's really easy to do that when you're an inner class. Again, this is not a Java course, but an inner class, when it's created, actually has an instance of the enclosing class that it can very easily call methods on and refer to the state and behavior of that enclosing class, which if the view holder were a separate class, that becomes harder. You have to then pass an instance of the fragment into it through its constructor or something like that, which I just don't want to have to deal with. So anyways, this is why I'm making it an inner class. I can make it private because I don't need to refer to it from outside the RecyclerView fragment, and I'll just name it something like my view holder, and I will have it implement the RecyclerView dot view holder. Whoops, I don't want to implement. I want to extend, and there's my first mistake. And I've got an error immediately because I have to implement a constructor that matches the superclass's constructor, which it is created with a view. Now, I know this view is a text view because I know what my layout is, so I'm going to create a text view instance variable called very originally mTextView. I'm going to use Alt-Enter to automatically import that text view. And then when my constructor gets called, I know that view that's being passed into me is a text view. I know this for not only because the layout that I created only has a text view in it, but because I'm in a few minutes going to be writing the adapter, and I'm going to actually be inflating that layout and then passing the text view into the view holder. But anyways, I know that it is, so I can safely cast the item that's passed into me into a text view and then keep it in a variable for use later. So this is it for a view holder. Its sole purpose in life is to hold a view, but you can imagine that that text view is not just a text view, that it's a more complicated layout, like a linear layout or relative layout that has 4 or 5 different widgets inside it. Maybe it's got text views, maybe it's got edit text, maybe it's got checkboxes or drop down lists, any number of widgets. And so this code right here, instead of just simply assigning it to a text view, I might do a bunch of things like edit text, my edit text, to ignore the typo for now, equals edit text item view dot find. Lots of typos today. Edit text item view dot find view by ID, and then give it the ID of an edit text in there, and maybe I've got a couple of different text views. This is my opportunity in the constructor to save all of those widgets so that I can use them later. But again, this is a simple text view, so I don't have to worry about any of that. And now I'm going to write, well, I'll skip this for now, and I'll go up to the adapter. So the next thing I'm going to do is create an adapter that will be used by my RecyclerView, and I'm going to call it my adapter, and it extends RecyclerView.adapter. And the reason I created the view holder first is this is the adapter is a generic type, and when you create one, you have to tell it the type of view holder that it's going to get and that it's going to work with. And in this case, my adapter is going to work with my view holders. So I specify that information. I get an error right away because it wants me to implement some methods that are required by an adapter, which is an abstract class. So it defines these 3 abstract methods: on create view holder, on bind view holder, and on get item count. And I'm just going to return those. So I'm going to do something a little weird. It's not something that we've done in class before, but I don't really want to go through all of the trouble of making a model just to demonstrate a simple recycler view. So I'm going to sort of create a fake collection here. I'm going to create a variable called size. Remember, we want all of our variables to start with the M for member variable. If they are member variables, that's just stylistic convention for Android applications. And then I'm going to create a constructor for my adapter that takes a size as an argument and sets the size of the collection. So this is an artificial collection, and I'm going to be able to create it to be of an arbitrary size. So you know, normally we would create a list of comic books or video games or objects that represent real-world items in a collection, or even synthesized items. and we would pass a list into this, and then we would get the size of the list based on the number of elements that were in it. But I'm saying, no, I don't want to go through all of that hassle. Instead, I'm going to create a fake collection that has some configurable number of items in it. So the first method I implement is get item count. This is supposed to return the number of items in the collection. This is so the RecyclerView knows basically when you're scrolling up and down when to stop asking for additional items in your collection because it's gotten to the end. And here I'm just going to return M size. So if I create this with 100, an integer that has the value of 100, this is going to return 100, which is the clue to the RecyclerView that my fake collection has 100 items in it. So the next thing that we're going to do is actually create a view holder. So remember, there's a conversation between the RecyclerView and the adapter right from the beginning. The first thing the RecyclerView does is say, okay, how many items are in your collection? This could be 0. We could return 0 because we've launched the app for the first time and we haven't added any comic books to our collection. We haven't added any video games to our collection. So 0 is a perfectly valid response to that get item count call, but in this case we're going to return a non-zero value. So the next thing the RecyclerView does is say, okay, I'm going to need a view holder for the first item in the list that I need to display. So I need you to create a view holder for me. Okay, so I'm going to actually create one of my view holders. And remember, my view holder needs to be created with a view. We know it's a text view. We actually know that it's stored in the RecyclerView layout file. So I'm going to create a layout inflator, and I'm going to create it using the context of the parent. So the parent view group that's passed into this method is the view group that is going to contain our view. It's provided to us by the RecyclerView. So I'm going to use its context to create a layout inflator using the layoutinflator.from method, which takes a context, and then I'm just going to call parent.getContext, which returns the context that that view group belongs to. It's probably our activity, our host activity, or the application context. We don't know, we just know it's a good context, and we can use it. Then the next thing I'm going to do is inflate whoops, typo. Inflate that view, and you see that the inflate method takes 2 arguments. The first is the resource ID for the layout that we want to inflate, and the second is the parent view group that we're inflating it into, which is this parent view group that was actually passed to us. There's another, here, let me go down a little bit. There's a third argument in the one that we want to use, which says do not attach this, this view to the view group parent that was given to us. Use that parent just to get its context, just for the purposes of inflating, but don't actually put this view that we inflate into that parent. We actually, by passing a false in for that third argument, and that's actually what we want to do in this case. If you do attach it to the view group parent, your RecyclerView breaks and everything blows up. Don't worry about the details, but we want to avoid that happening. So we're going to use the overloaded version of the inflate method that takes 3 arguments. The first argument is the layout that we would like to inflate, which is our RecyclerView layout, and the second argument again is that parent, and the third argument is false for do not attach my view to the parent after you inflate it. Keep it sort of free floating view. And then the last thing that we do, we just return a new my view holder that holds this view. Okay. So remember, a RecyclerView is going to create some small number of views. So my collection could have 10,000 elements in it, but the number of views that will physically fit on the screen at any one time is going to obviously be a much smaller number. It's going to be something closer to maybe 10, 20 different views depending on how big the screen is and how big my text views are. So we want to make sure that we reuse those views as much as possible as the user is scrolling up and down on the screen, which is what the view holder is for. The view holder holds on to a view so that it can be reused later. The RecyclerView does not want to, if the user is scrolling really, really fast, it does not want to create hundreds and hundreds of views, because this is an expensive operation. It's creating objects, it's inflating them, it's displaying them on the screen. All of this takes computation and memory that we don't want to waste. So rather than create a new view every time an item comes onto the screen, we want to reuse views that have just scrolled off the top or bottom of the screen. And the recycler view is smart enough to do that, but it needs a view holder to hold that view. So as it goes off the top of the screen, it can get a reference to that view and reuse it when it comes back up on the bottom of the screen. Okay, so onCreateViewHolder gets called a few times. Let's say we can fit 10 views on the screen. OnCreateViewHolder will get called maybe 20 times because the recycler view is smart enough to create a few more than it needs, so that it can have some in a buffer essentially off the top and off the bottom of the screen, so that scrolling is faster and smoother. But it's not going to create many more than that. And then onBindViewHolder is the last method that gets called on our adapter. Now you might be tempted to, and again for very simple view holders like the one we have that has only a simple text view in it, it's very tempting to just write the code necessary to bind the value at this position in the collection to the view in the view holder right here. And if it's one line of code, if you can literally just do something like holder.mTextView.setText, and then let's just for a second pretend that we have a list of strings, and you can just say strings.getPosition. If that is what it takes to bind your view to a new value in your collection, great. You know, it's one line, no problem. You can do it here. That's perfectly acceptable. However, if you have one of those more complicated views that I was describing earlier, where maybe you have, let's use the comic book example from a few lectures ago. You've got the title of the series, you have the volume number, you have the issue number, you have a Boolean value which indicates whether or not this comic is actually in your collection. Maybe you have more information, like the author who wrote that issue of the comic, the artist who did the pencil artwork for that, the artist that did the ink artwork, the artist that did the coloring, the individual that did the lettering, the editor, so on and so forth. Maybe your comic book has 10, 20 different attributes that you, some of which you want to display inside your recycler view. You're going to need text views and edit texts and checkboxes to display that information, so your view starts to become more complex. And you really don't want to, in this method here, be pulling all of that information out of the view that's inside the view holder and writing 10 lines of code here to bind all of those different views to different parts of your model. Why don't you want to do that? I've talked about this in the lectures before. We have a core concept that's a core part of object-oriented programming, and that concept is called cohesion. And we want objects that are more cohesive, which means objects are designed to have everything they need to do their job and nothing more, and they don't need other objects to do their job for them. And we don't want to create coupling between two objects any more than is necessary. And coupling is basically dependencies between two objects where they rely on each other more than they should have to naturally to do their jobs. So the natural job of a view holder is to hold a view. That's what the view holder does. It holds a view or views. You know, it has one parent view group, but perhaps it's got several views inside that. The view holder is the one that has the very close relationship with the views in our layout. And so therefore it makes sense for the view holder to be the one that does the work of setting the values on those view holders to update them so that they represent an item in our model. Makes much more sense to do it here. When it's one line of code, it's a harder argument to make, but it even still makes more sense to do it here. So instead of trying to do the binding in the onBind view holder part of our adapter, I'm going to do it inside my view holder. So I'm going to add a method, public void bind, that takes, in this case it's just a position, but in a more complicated example, this might be my comic book or my video game. It might actually be the model item that I'm binding, but for this simple case I'm just going to display in the text view the number of the item in the collection. Remember, we're creating an artificial collection. All it really has is a size. It could be 0, it could be 100, it could be 1,000, it could be 100,000. But this text view inside my view holder is just going to display that position plus a little bit of additional information, which, well, I might as well add it right now. I'm going to add a private int m number of times bound. And I'm going to use this to show you the number of times that one view holder is bound to a new item in the model over and over again. This more than anything else demonstrates that we are reusing our view holders because they get bound more than once. And initially, when a new view holder is created, I'm going to set the number of times bound to 0. And then whenever this bind method is called, I'm going to increment by 1. And for those of you who have taken Java courses with me, you know I don't like the increment and decrement operators because it's way too possible to make mistakes that are really hard to track down later. So I'm going to say increment this by 1 the long way. And then I'm going to set the text on the text view to be something more complex. I'll create a new string that's something like, I'll call it message, item number, and I'll set it to the position. And then in parentheses, I'm going to say bound times. Okay. So this is the value that I'm going to display on that text view. Basically, it's just going to tell us the item number in the collection that it would be bound to if we had a real collection, but we don't. It's a fake collection. So it's just an artificial position in our artificial array. But then it's also going to tell you the number of times that this, the view held by this view holder, the number of times this view holder was used to bind that same view to a new item in the collection. And I'm going to set this value on my text view, and if all goes well, when we scroll up and down, we'll see different items in the text view, but we'll also see that the same view holders are being used again and again. So then I'm going to scroll back up, and I'm going to change this. Instead of trying to do the binding inside the adapter itself, I'm going to delegate that responsibility to the view holder because cohesion and coupling tell us that this is a better place for the binding to happen. So I'm going to call holder.bind and just pass the position into it. It's that simple. Now you can imagine, again, if we had a collection of comic books, I might do something like comic equals comics.get the comic at that position, and then I would actually pass the comic book into there. And then inside the bind method, I do things like pull out the series title, pull out the author, pull out the artist, pull out the issue number and volume number, all of that stuff. But again, artificial collection, just passing in an artificial pointer that we're going to display on the text view in our artificial collection. So the next thing we need to do up in our RecyclerView fragment is actually get the RecyclerView out of the layout. So I'm going to call view.find view by ID, and remember, I named my RecyclerView with RecyclerView up at the front, so it's very easy for me to find it. I just start typing RecyclerView, and bam, autocomplete recommends the ID for my one and only RecyclerView. If I had more, you know, I'd give it a more meaningful name so I could tell them apart. But I highly recommend doing this so that you don't get stuck trying to remember what weird name you gave your widgets in your other layout. If you name every text view starting with text view, as you can see, the other autocomplete I have there is text view for RecyclerView. It's very easy to find them. So I'm going to get the RecyclerView. I'm going to, whoops, I forgot my cast. This returns a generic view, so we have to actually cast it into RecyclerView. The first thing I'm going to do is set the layout manager to a new linear layout manager. I always forget what argument is missing here. Is it the context? Good, it's the context. And then the next thing I'm going to do is set the adapter to a new instance of my adapter. And remember, I have to tell my adapter how many items it has in its collection, so I'm going to tell it has 100 items in its collection. And here I'm pretty much done, but all we have at this point is a fragment. Obviously, oh, I guess I did make a mistake here. Okay, you may have seen the screen jump a little bit. That's because I was trying to figure out what the problem was, and I didn't want to make you guys sit here and listen to me go for the next 5 minutes. Of course, the problem is that RecyclerView is in a support library, the V7 support library, which relies on the V4 support library. The fragment that Android Studio generated for me extends the standard Android fragment, and what RecyclerView wants is the context that you would get from the V4 support version of the fragment. So the first thing I'm going to do is delete the import statement, which is going to cause this error saying, okay, now I no longer know what a fragment is. I'm going to then use Alt-Enter to get the import class option, and I'm going to select the V4 version of the fragment, which makes that error go away. Now my linear layout manager is happy. It's getting the V4 version of the fragment and its context, which is what it expects. And I can create my new layout manager and set my adapter. So now we have a fragment, and we need a host activity to host that fragment. So I'm quickly going to create a new empty activity. Remember, empty instead of blank, so that we don't get all of the marshmallow garbage. Going to call this RecyclerView activity. I'm going to very quickly go to my activity RecyclerView layout, which was added. I'm going to change my relative layout to a frame layout. I'm going to give it an ID. Again, autocomplete, autocomplete. Name it frame layout RecyclerView. And then back in my RecyclerView activity, yes, another wonderful aspect of Android Studio, when you create an activity in a subpackage, it doesn't automatically import the generated R class for you. So I'm going to import R, and then I'm going to get my fragment manager. I want to use the support fragment manager because again, we don't want to get our V4 versions of classes mixed up with our standard fragment manager classes. I didn't have the option to pick between the V4 and standard fragment manager here, and that's because I'm calling the get support fragment manager method, which only returns a V4 fragment manager. So I didn't. IDEA is smart enough, or Android Studio is smart enough, not to ask me to pick between the two different kinds of fragment managers, because it knows that this must be the V4 version of the fragment manager. So then I'm going to begin a transaction. I'm going to add a new fragment to r.id.RecyclerView frame layout RecyclerView, and a new RecyclerView fragment. And then I'm going to commit that transaction, and that should be everything that I need to do to get my RecyclerView displayed in this activity. The last thing I need to do is go very quickly into my main activity. I'm going to copy the button that already exists in here, and I'm going to add a new button to launch my RecyclerView example, and I'm going to set the oh, sorry, this is a holdover. I'm inside a linear layout, so I shouldn't be using the center and parent attribute. I want the buttons to display one on top of another. Let me set my orientation to vertical, and I want to change the text that's actually displayed on the button to be RecyclerView example. Extract my string resource. I tend to call all button labels label underscore something. Okay, and I want to add an on-click listener here that's going to start my, I'll call it RecyclerView example. I'm going to use Alt-Enter again to create the RecyclerView example method automatically in the main activity. And then I'm going to call start activity with a new intent this and RecyclerView activity dot class. Okay, all of the pieces should be in place now, and I'm going to run my application, and I will run it on Nexus 6P emulator. I'm going to pause right now while the emulator starts up, so that you don't have to watch it. Okay, so the emulator's up, and this is another thing that happens to me all the time. The emulator started, but the application didn't. So when I unlock the phone, we're going to see that the application is not running. I'll go back in here, and you can see I have a whole bunch of apps running down at the bottom. I don't care. I'm going to just click the play button up here again to start it, choose my emulator that's now running, bring it back up to the top, and assuming that I didn't introduce any bugs, it should start up. And now we have my RecyclerView example button, which, fingers crossed, starts my RecyclerView. Okay, so now we can see, remember we have a fake collection that has 100 items in it, and because our text view is just a very simple text view with the standard font size, which is pretty small on a phone of this resolution, we can fit 24 of them on the screen at once. In fact, you can see just a little bit at the bottom. There's a couple of pixels that you can see that are showing of the next item in the list, but we've got 24 of these views on the screen at once, which means that the RecyclerView probably asked the adapter to create, maybe twice as many. So maybe we've got 50 view holders in memory. That's probably more than we have. We'll see in a second. But we can see that each of these view holders has been bound once. So one view holder, one view, but the view gets reused to display items as we scroll up and down. But so far, because we've only displayed these items, the list once, we haven't scrolled at all, they've all just been bound one time. Now, if I start to scroll up, we'll see, okay, oh, look at that. Remember, the first item we saw, or the last item we saw on the list was item number 24, and then we see 25, 26, 27, 28. So we know the RecyclerView had created only four more views than it needed to display on the screen. And then as we started to scroll, oh, look at this, item number 29 and 30. We know that these are views that were used probably to display item number 1 and 2 in the list up at the top. When it scrolled off the top of the screen, the RecyclerView immediately asked the adapter to bind in anticipation of those items coming up soon in the direction that the user is scrolling. The RecyclerView asked the adapter, please bind these views to a new item in your collection. And so we can see that they're displaying the right number, 29 and 30, exactly what we'd expect. They don't say 1 and 2 on them. But the bound 2 times indicates that this view was bound more than once. And if we scroll, continue to scroll, and then as we go up past number 57 or so, now we're starting to see views that have been bound 3 times, 4 times, and then we're at the end of the list. If I scroll back up, oh, it's now taking views that are going off the bottom of the screen and binding them again. Some of them 4, some of them 5. See, it's not in any particular order, it's unpredictable. But some of these views have been bound 4 times, 5 times, 6 times. In fact, if I scroll up and down really quickly, we can see that the views in the middle of the list still only bound 4 or 5 times, but the ones at the top and bottom are being rebound again and again and again as I scroll up and down. So as the views fall off the bottom of the screen, they're bound to items that are coming up on the top of the screen. And as views go off the top of the screen, they're bound to items that are coming up off the bottom of the screen. Again, same views, same 28 views or so being reused over and over and over again. Notice we don't see any 1s and 2s in here. New views are not being created. These are all the same 28 or so views being bound again and again and again to items. And as you do this, you can see the numbers really start to get high. But now we've got a view that's been used 53 times. So the same view recycled to display different items in the collection 53 times. It could be the same 3 items that it's just getting bound to over and over again, but it's being rebound. And this is what the recycler view does. In a very efficient way, it creates just a tiny bit more than the absolute minimum number of these views that it needs to display on the screen at a time, and then it just reuses them again and again and again to conserve the overhead and in the form of memory and computation that's required to create new views. You can imagine that instead of 100 items in my fake collection, I created a collection that had 10,000. I don't want to force my phone to create 10,000 text views when I only need 24 to display on the screen. So that's what the recycler view does.